So Marcin just introduced this talk a few seconds ago in a way that you couldn't hear. Just to repeat it, he says, I want to die.
Yeah.
Does anybody else feel that way?
Yeah, I had the laptop
there's
in
one.
my second session, and I've forgotten to bring it here. Okay, so
Yeah,
welcome to this presentation titled Zero to Multi-Cloud. We're happy that you're here. We have quite a few things to talk about, and we don't have any time at all, almost.
But as a quick preview, I think this is going to cover really like contract testing.
Yeah, we're going to show you the, let's say, deployment pipeline, how it could look like, and we're going to show you how a good build should look like. Actually, the other way around. First, the build, how you should fail fast. Actually, you should fail your builds even before going to any sort of a deployment pipeline. And then we're going to show you how you can leverage a stateful CD solution to, let's see, do interesting stuff in terms of a pipeline.
Yeah.
Okay, so we have a story to tell. So there's a Joe. Joe is a developer. This is Joe. And Joe used to, let's say, write some software in his previous job. And Joe has done quite a few bugs in his life, miserable decisions. So this time, since Joe is in a new company, Joe decided to do things properly. So Joe, of course, has to create a microservice, right? Because everybody does microservices. Joe has to create one too. So Joe thinks like, okay, this time I will see and look around what people do around me. So it turns out that they use what? Spring Initializer. So they generate projects like Spring Boot projects. So Joe is happy, finally, microservices with Spring Boot, it's going to be great. But how should I deploy it? Now, Joe looks around, and there is a situation. So it turns out that there are many tools, because, of course, it's not the case in your companies, but Joe's microservice is extremely special, right? It's not doing like anything that the other microservices do. You don't build it and deploy it. No, it's more complex than that. And other developers think in the same way. So Joe thinks like, what should I use? And again, it's like a hypothetical company, not the case in your companies. Joe decides to pick yet another tool, right? Because all the 4 existing ones are not good enough for his special case. And of course, Joe has a very specific deployment pipeline to build. So it looks more or less like this. Of course, it's a simplified version. So Joe has to also decide where to deploy his app, because some apps are deployed to one cloud, the other apps are deployed to another cloud. So Joe decides to do what? To deploy his app to yet another cloud, because this is the special cloud where his special microservice should be deployed. So after some time, Joe is not really happy, because what he created is absolutely unmaintainable. So what is a good build, right? Let's try to fix the situation. Let's try to first fix Joe's build. So let's say that we have some sort of a build in our CI system. So the problem we're trying to solve is slow feedback, right? So Joe doesn't want to, wait until the end of the whole deployment pipeline to see that there was a typo in the API, for example, right? We want to fail fast, even during the build time. Actually, we're trying to push down to the build time as much as possible. So if integration is faulty, or if the API is changed in a backward incompatible way, we want to verify this during our build. So there's a Captain Obvious solution to this. If the problem is slow feedback, you should fail fast. Nothing special, unit integration tests, you all do it. Actually, I'm pretty sure that you don't write a single line of production code without a test. Like everybody does it like this? Okay, not a single person, that's unexpected. Okay, so to test faulty integration, you can use different tools that, let's say, implement the contract testing approach, one of which is Spring Cloud Contract. You can leverage this for HTTP or messaging. Today we have around 30 minutes with questions, and I have sessions about Spring Cloud Contract that take an hour. So this time I'm going to show you that in like 2 minutes. So what is a contract? A contract is an agreement between 2 sides of the communication, like a producer of the API or a producer of a message and a consumer of that API or a message, on how the communication should look like. So it's not a schema. It's just a scenario of how we're going to use your API. So the producer defines a contract, and from the contract, tests are generated. Because, let's say wiki pages are great, sending emails with agreements is great, but it's better to have something from which we can generate a test to verify if it's true. So from the contracts, we generate tests to see if the producer is not lying, And we also generate the stubs, right, from the contract tests and stubs. Since the stubs are pushed to like a common place, Git repo, Nexus, Artifactory, something like this, they can be reused. And since they can be reused, you can have multiple consumers consuming the same API, which will be, it's a verified, and the stubs for which will be created once, so you don't waste the time. Which means that if you have this whole automated process, you can fail at build time if integration fails. And let's do what we love the best, so code on the slides. Let's check out the demo. Let us assume that we have a very simple system. We have GitHub that emits HTTP messages. We have a GitHub webhook application that listens to those messages and sends out AMQP message. And GitHub Analytics is the other service that polls for those messages. So GitHub webhook is the producer of an AMQP message, right? So we will define a contract. You can define a contract in Sprinklr contract using YAML or Groovy. Here we have Groovy. There's all sorts of details here. Let's focus on this one. So we're saying that the producer says, I'm going to send a message to destination messages with such a body. The body contains fields username and repository. Let's focus on this. So now, on the producer side, the plugin of a, let's say, Sprinklr contract, Maven plugin or Gradle plugin reads the contract definition and produces tests and stubs. So this is a generated test. It's not, human didn't write it. It's a generated test. And let's now go through the tests. How was it generated? So in the contract, we said that the message will be triggered by some method. So there you go. The method is there. It's going to be executed. And then we expect that the output message will be sent to a given destination. If you're working with messaging and you have some sort of testing frameworks, they very rarely test the concrete destination to which a message is sent. And then on production, you can have messages sent to one queue and you listen to another one, right? I mean, the feature is working, but not really. So here we're verifying if you're sending messages to the proper destination. You've defined some headers. Let's verify if those headers are correct. And the same with the body. And now you can see that we verify whether the body contains username and repository. Fantastic. Let's go to the consumer side. So the consumer expects that the message will contain fields, username, and repository again. So inside the consumer tests, a component called stub_runner will fetch the stubs from Nexus and will store them if those are HTTP stubs, or you can reuse them if those are messaging stubs. So you can reuse them when you run the tests. So this is such a test. Via some annotations, we say, hey, we want to download the stubs of GitHub webhook, the producer. Initially, we had 0, let's say, messages stored, right? And then we defined in the contract that you can trigger that message, trigger the stub. So here we do it. We trigger a message via label called issue created v2, and what has been defined in the output message section will be actually sent. So the framework will send a message with body, username, and repository to a destination called messages. If you listen and to that topic, and if you know how to deserialize properly, you'll pass the test. Great. So this is the first thing about contract tests that you can, on the build side, verify if things work fine. What if they don't work fine? So let's assume that somebody's insane and decides to break the compatibility. So we no longer have username and repository. Now we will have user and repo because it's shorter, right? So why not? We're going to save some bytes. So GitHub webhook, let's say, uploads the stubs to Nexus, the broken ones. And now if we're on the consumer side, what happens is the build will be broken. Why is it so? Because we're going to fetch the fresh stubs from Nexus. And we're going to trigger the message with the body that is broken in terms of compatibility. And we will have a constraint violation somewhere because we are missing the fields. So via contract tests, you can immediately, when you run the build, verify if compatibility was broken. So we're going to say, how can I actually prevent from happening? So we can verify whether that the producer is not going to production if the compatibility is broken. So let's take another example. Let's say we have HTTP. So GitHub Analytics is the producer of the HTTP endpoint, let's say issues, to which you have to send a delete method call, right? And we defined a contract where we express that we have such an endpoint. So if we check out the contract, it looks like this. We have a method delete, URL issues. If you send such a request, you're going to get status to 100. Such a test will be generated where we say, we're going to send a request with a delete method to endpoint issues. If that's the case, we're going to verify if status code is to 100. Great, we've gone to production, awesome. Now, again, somebody's insane and decides to remove the issue because why not? So we remove the issue, the endpoint from the code, and we remove the contract. No tests are generated. Life is great because here's the patch. If you don't trust me, I've removed the mapping and I've removed the contract. And now what we want to verify is whether our current code works with the contracts that are, let's say, from the application that is currently on production. And here we could actually ask some sort of a stateful CD solution. What is the current version on production, right? Typically your, let's say, homemade CI, CD tools don't know this, right? Because they only deploy and they don't store the information about what's currently there on production, right? So here we would ask a stateful CD solution, like give us the version of the app that is currently on production. And here we'll see that if we have removed from the code an endpoint, but the currently deployed to production app defined in the contracts that it has these endpoints, something will blow up. And that's absolutely what's going to happen. So if the producer tries to do a breaking change of the API, the build will be broken. The producer will not go to production. Because we're trying to build V2, but we don't support contracts of version currently being in production, which is V1. So this test will be generated from old contracts, but it's going to break because we have removed the endpoint from our code. So we're talking about stateful CD solutions, so
Sure.
maybe you're going to tell us something about this?
Sure, sure. So, I mean, Marcin's been talking about a very specific form of testing here, contract testing. One thing we hear quite frequently is that organizations have, you know, say, a suite of, we'll call them microservices, that are so interdependent that they feel like they need to release them together, they need to test them together as a bundle. Much effort has been spent on developing tools to allow you to, you know, kind of like deploy all these things together and test them as one piece and so forth. It really kind of hurts ultimately. It kind of prevents you from doing higher order operational functions like zero downtime upgrades and zero downtime rollbacks of versions, because of course you're not just upgrading one application or rolling back one application, you're upgrading or rolling back a suite of them. So anything we can do to break up this, you know, these multiple applications into units that can be tested independently, which then allows you to do, you know, to do more best practice safe deployments, is a good thing. And contract testing is a really good example of where we can use these contracts to validate our integrations at build time rather than having to deploy both services together at once. Here's a particular application, and I'll get into the resource model on Spinnaker tomorrow in the longer breakout session on Spinnaker if you are interested. But we have a single application demo here, which is actually deployed to two different Cloud Foundry foundations, one called Dev and one called Prod. And we've used the red, black, or blue-green deployment strategy to deploy this application. So what we have is V017 of this code running currently with 4 instances. That's the 4 green little chiclets you see here. And then we have 4 disabled versions of older versions of this code. So Spinnaker would allow me to do something like quick rollback here. And the rollback would exercise whatever needs to be exercised down on this particular cloud platform, which is Cloud Foundry, to re-enable the old version of the application and wait for platform and application health to report healthy, and then move the route back over, right? Now imagine you try to do this kind of thing with, you know, a 3 application Hydra, you know, that was kind of tightly connected together. There's really no way you can roll back all 3 at the same time and wait till they're all, you know, in sync together. So And so that's kind of why we're focusing on something like contract testing as a way to break down these boundaries. For the particular, what was it called? Stub runner? This one? Just to kind of visually see a process here, how complicated a delivery pipeline could look, or just how much sophistication could be in it. We could have a configuration here which triggers based on the completion of a Jenkins job. So already you see a clear division between continuous integration and continuous delivery. The continuous integration server is responsible for building the code, running unit tests, running contract tests, and then producing an artifact in Artifactory or on GCS or in Nexus or wherever you want to put that. It could be a Docker image. It does very much depend on what your deployment target is. So at the point when the deployable artifact is produced, that's when the CD pipeline starts. And so the CD pipeline could contain things like prepare the test environment, which I believe is like making database changes, or is that what's going on there?
I'm going to talk about this in a second.
Okay, but you just see how long it is at any rate. Deploy to test, run tests, deploy to the test to the latest prod version, et cetera. And so we kind of move our way up through the staging environment. We have a manual step here to approve for production deployment, deploy to production. So there can be many stages that go into the CD. Okay, go ahead.
So without a stateful CD solution, it's actually very difficult to actually know what is there on production, what's the latest version. You can mitigate it by different approaches, but it's all like poor man's version of a stateful
And let's get specific about that. Like suppose as part of your Jenkins build, like you had a Jenkins deployment pipeline, and at the end of that Jenkins deployment pipeline, you did something like tag your source repository with the latest production version, and you try to query that information to determine what version of the code to run your contract tests against. You saw when I went over to Spinnaker and I clicked server group actions rollback, it's these out-of-band actions that happen that aren't deployment actions. When I'm rolling back or I'm doing something that breaks that down. And that's why anything like this that requires some knowledge of what the current production version is, it's good to hit a stateful CD solution like Spinnaker to get that information. Go ahead.
So let's check out, let's say, a good pipeline, how it could actually look like. So one of the problems we're trying to solve is we're talking about zero downtime deployments and things like that. So if you break API compatibility, you can't do really zero downtime deployment because you can't have two apps running at the same time.
Right.
Because let's say if you have round robin, every second call will be returning for 104, right? Because you've removed an endpoint.
Right.
What about database changes, right? You can have a platform that allows you to do zero downtime deployment, but if your changes are backward incompatible, you cannot have two apps running at the same time. So rolling back a database can be problematic. And deployment pipelines should test if you can actually do a rollback, right? A rolling back database changes is extremely difficult, especially if you deploy every 6 months. Of course, you deploy every day or a couple of times per day, but there are companies out there that deploy every year or every 6 months. So how can you roll back a deletion of a column? That's kind of problematic. You can say, we use such frameworks that you can provide a rollback script, and if you don't have it, we're going to break the build. So in one of companies I work for, somebody used to write select 1 equals 1, so there's anything there in the rollback script, and the build passed, right? I don't think it's a good rollback script, select 1 equals 1. Some schema versioning tools don't even support the concept of a rollback. So again, Captain Obvious solution. If rolling back a database is difficult, maybe don't do it, right? So what if we have an option to verify, and let's say we have this assumption that you always do backward compatible changes, or, and that's difficult to pronounce, backward and compatible changes in a backward compatible way. That's possible to be done. You can read my blog post, Zero Downtime Deployment with a Database, on how to do it. Once you read it, you will never rename a column again because you don't want to support 5 different deployments to rename a column. You'll say that the name of the column is absolutely the best in your life. So what you can do is actually roll back the app. You will leave the database, but roll back the app, for example, the jar. That way, both application and DB changes have to be compatible. And that way, old app and new app will work together at the same time against the new version of the database. And how can we leverage a deployment pipeline to verify this? So we're going to have GitHub Analytics again. Inside the code, we use repository as a name of the column. And inside the schema, we have repository as a column as well. So we use, for example, Flyway. We define a SQL script to define the schema. So once we start the app, it's going to upgrade the schema to have the username and repository columns. So now we go. My monitor is not large enough, so I have to, scroll it combine it with arrows. But it's exactly the pipeline you've seen, like John has presented. So we go from the beginning, like to the top left to the bottom right. So we go through the whole deployment pipeline, and what did you do? Oh, it's over here. So let's say that we've gone through the whole deployment pipeline, and we've managed to go to production.
Oh, you're done with that then?
Yeah.
Sorry.
Thank you, John.
I'm trying to be helpful.
So helpful. So this is the initial state.
Stand over here now.
So it's the initial state where you're pushing me aside of the schema. So we have repository and username in the database, right? So now, again, we have the same person who's insane and decides to rename the column because typing less is better. So we rename the code to have repo in it and the database to have repo as well. So that person creates this very specific file called v2 breaking change as a hint and changes the name of the column from repository to repo. This is the new schema, right? Repo. So now what's going to happen is, again, what we would like to verify is whether currently deployed version to production, again, we would like to ask the stateful CD solution, give us the latest deployment to production. Does it work with the currently modified version of the database, right? And of course, it will not, because in the code, it assumes repository. In the schema, it has repo. So we would, in the pipeline, for example, in the prepared test environment, we would start, let's say in Cloud Foundry, we would start the MySQL service, Rabbit service, whatever. Then we deploy our build application to Cloud Foundry, this special, let's say, space. And we bump the schema when the app starts. For example, Liquid-based or Flyway starter would upgrade the schema to V2. We run some smoke tests. The tests pass against V2 of the schema and V2 of the jar. Great. So now we ask, hey, Spinnaker, what's the latest version? Oh, it's V1. Great. So let's deploy it, V1, and connect it to the new database, so V2. So code assumes that the schema contains repository, but in reality, the test will break because the schema contains repo. So inside the logs, you will see unknown column repository. And we have just saved a large amount of money because we managed to break within the deployment pipeline, and we didn't go to production with a breaking change. So that was fast.
We made it.
Yeah, we made it, and I didn't die. So what we managed to show you was how you can leverage a stateful CD solution, or like first, how you should do your testing to break as soon as possible, to break your build when your API compatibility is broken, when somebody else is breaking you. You should have a lot of unit integration tests because they don't cost a lot of money, contrary to end-to-end tests and deploying to various places, right? And thanks to the stateful CD solution, we have monitoring of what's there on production on different clouds. And we can ask the stateful CD solution, what's the currently deployed version to production, and we can leverage in our tests. And I think you didn't mention that for different clouds, the UI would look pretty much the same.
It'll look the same. Yep.
Do you have any questions? Does it make sense?
Do we have any time?
Come again?
We've had that problem where we couldn't go back because of not know what the database is.
So the comment was that there was a couple of times lack of possibility of rolling back because of some constraints on the database. There was a question there, I guess, right?
Yeah, I mean, a lot of our test push, like, structure, especially like test files sometimes, should be using Spinnaker for that.
So the question was if, because you're deploying not to production, but some other test cloud, right? And sure. And should you use Spinnaker for that? So actually, the deployment pipeline we've been showing uses exactly Spinnaker for that. There's no reason not to use anything else but Spinnaker for that. Because why should you have different tools to do exactly the same thing, right?
In essence, the pipeline could be one, all the way through. You could break it down into 2 pipelines if you care to, but you can imagine having a manual judgment stage at the end or some sort of blocking, gate before production, if that is what you need right now. Not quite yet. Yeah, I think we showed you in the configuration screen there Jenkins as a trigger. We'll make sure that concourse is a trigger ultimately as well. There's other triggers like pub sub and so forth, but so that's to come as well.
The alternative, I guess, would be to monitor whether there's a jar somewhere.
That's right. So you could do that. If you're publishing the jar to, say, GCS right now, you could do a pub sub hook on that. So there's other ways around it, but yeah. Yeah, part of what, the answer is yes, and what it would typically look like is you have some sort of, that multiple pipelines represents multiple applications, I'm assuming. And so, it's kind of awkward, I think in an intentional way. You may have another synthetic application that represents whatever the set of those things represents, and that pipeline could do potentially some work, taking a manifest, splitting it up into multiple pieces, and then triggering other pipelines. So pipelines can trigger other pipelines. You can do that. But kind of like we said, yeah, kind of like we said, I know that's where a lot of folks are going to start. We do want to discourage it because you can't get to that point then where you do zero downtime deployment, where you can do effective rollbacks, where you can do canary analysis. So, not necessarily a terrible place to be in right now, but it's kind of something to try to evolve towards in the future.
Oh, the question was there, does it integrate with Concourse?
I guess we did not repeat it.
Yeah, so the question was again, does it integrate with Concourse? Not directly, but you can, let's say, in Concourse, upload a jar or an image somewhere, right? And make Spinnaker, let's say, poll for updates on that repo, right?
And Concourse integration is something our team will provide in short order, so as a trigger type.
Any more questions? Any more questions? The question was, how do you deploy Spinnaker?
Talk to me afterwards. We've got something for you. I think there'll be more forthcoming publicly on it. We're testing it with a few customers right now, but we do have a process and can help you with that. Yep.
Any more questions? So if there are no more questions, thank you very much.
Oh, thank you.